Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining me from. Thank you for joining me this live TV session. My name is Arjuna Christian. I'm Program Coordinator for Data Scientist at AMOE. This will be our second data science coding session for the winter 2023 cohort. See someone already on YouTube and also on Zoom. So what we'll be dealing on today will be machine learning, classification, modeling, and analysis. And just like an end-to-end running and modeling, doing tuning of hyperparameters and all. So without wasting much of our time, I guess everyone can hear me clearly. Good. Without wasting much of our time, I'll just share my screen and we'll begin. Okay, I believe everyone can see my screen. All right, so what we'll be doing on today will be working with a data set called a heart disease data set. We'll be predicting heart disease using machine learning. So the difference between regression problem and classification problem, you are predicting if something is this or that. For example, in our case study, if a patient has heart disease or not. So the problem involves binary classification, as a sample can only be one of two things, which involves using a number of different features, pieces of information about the person to predict whether they have heart disease or not. So the data was gotten from Cleveland database from UCI machine learning repository. You should know that. So these are the features of the data sets. It has the age column, sex, and all. I'm not going to dwell more on that. So these are just the features of the data sets. And the problem I'm working on are classifying if a patient has heart disease or not based on these features gotten from, let's say, the hospital, based on how the data set was arranged from the Cleveland database. All right, moving on. As usual, so as not to waste time, I've already written down the code. So as we're running the code, I will explain as we move on. So for those just joining, just remember that we're working with a classification problem predicting if a patient has heart disease or not using machine learning. Okay, let's begin. We're running the first line of code, importing necessary libraries, non-passive, non-public, and all that. And also importing, like the way I normally like how I do my own, I import most of the libraries I want to work with. So this other place I imported 3 classifiers I want to use: random forest, k-neighbors, and logistic regression. But if you're doing yours as you are progressing, you would know what you want to use. But based on I've worked on this before, so I already know what I wanted to use. So that is why I've already imported these libraries. So also the trim test splits, function matrix, and all. So moving on, load the data sets. I already have it in my drive. So this is the features of data sets. Okay, I believe everyone can hear me. You can't just drop it in chats. So I know I'm not just talking to myself. Okay, moving on. Loading the checking the shape of the data sets. So our target column, which is this part in data sets. Like I said, the data set has the age, sex, the different features gotten from the hospital. So our targets column is this target, which is 0 or 1. 0 means No. 1 means yes. So carrying out some few exploratory data analysis on this, finding out how many classes there are in a target column. That's what this code is doing there, target and value bands. Okay, so we have for 1 there's 165, for 0 there's 138, so it's quite not that balanced with statistics. Balance, doing some visualization to understand our data set better. So for the target column, this has already been, if you notice, data set has already been processed. So normally, if this target column could have been 0 for no, 1 for yes. So for now, what this represents is that in a column in our data set, we have 165 for yes and 138 for 0, which is no. So these are target column which we use in making our predictions. So getting the info of our data sets, checking for missing data. There are no missing data in these data sets, so that's good. So it saves us stress of cleaning and all that. So this was how the data set was gotten from the Cleveland database in the UCI machine learning repository. So running describe to know our data. So these are the mean, the standard deviation, 20 percentile, and all. So this is just like a quick way of understanding your data set better. I'm not going to dwell more on that. So moving on. So I'm going to do some few exploratory data analysis before I get on the model. So I'm going to check the heart disease frequency according to the sex, because in our data set we have the sex column, which is male or female. So let's see the value counts of the frequency according to sex. So if you notice from our data set gotten, the sex is for 1, which represents male, 207, for 0 represent female, 96. So mind, like I said, this data set has already been processed from the Cleveland database. So if it wasn't processed, this 1 and 0 represent male and female. So meaning there are 207 males and 96 female. So let's do a cross tab. So this explains it better. I'm also putting it in a plot to in a visual to understand better. So what this code is doing is cross tab I did here. I'm plotting a bar chart to understand this target and sex column better. So this is what this code is doing. Y label plotting the X label on using a matplotlib bar chart. Plotting this. So if you can see from this visual, the heart disease frequency for sex. This visualization explains the target column to the sex. So for the sex parts that has no, which is 0, which present no disease, the seems that the male, that's from our data set, seems that the male has the male column, they had no disease compared to the female. Then for those that had the disease, also the male had more compared to the female. But from this can deduce that the female had disease more than the male. From this visual, that's what this visualization is explaining. So the red is for the female, this other color, golden red is for the male. So this is a way to understand your data set better. That's why you still need to do some visualizations when carrying out your exploratory data analysis. All right, so moving on, checking another column called the talach to know the value counts. So another exploratory data analysis I have to carry on is the age versus the mass heart rate for the disease. So if you go back to the description of the data sets, the mass heart rate column, which is okay, yeah, which is this. So I'm trying to see the correlation or the analysis between it and the age. So when I run the code, you understand. So I'm plotting a chart that will show me to understand better. Okay. heart disease is a function of age and the maximum heart rate, which is this large column in your data set. So what this code is doing, it created a scatter plot. This first piece of figure will give me the figure size. So that this figure will be big. This is what this first line of code is explaining. Then I'm plotting a scatter plot with the data, which is the target column, the age, and the target column, which is 1. So the age and the target column, which is 1, meaning disease, then versus the mass heart rate column. And also another scatter plot of the age, whereby the disease, there are no diseases compared to the mass heart rate. Then I'm plotting both of them to give me a scatter plot. So for my visualization, the red represents disease, the golden rod represents no disease. So this is also another way to understand the data set better using visualization. All right, so moving on to the next code, plotting a histogram of the age distribution of our data set. If you notice, we have in our data set, we have those of 60 highest in our data sets. That's probably those in the 50s to the 60s, more less than those in the 30s. So this allows you to understand your data sets. So another exploratory data analysis I want to carry out is the heart disease frequency past chest pain. So this is just me trying to explore my data sets. So I will also get to the modeling aspect. So this will be essential to those in data analysis track too. So this is a way of understanding your data better, so you know when you're carrying out your modeling, understand what you're doing. So just run the code. And also plotting a bar chart. Let's run this code. So this is the heart disease frequency per chest pain type. If you notice in the data set, we have different chest pain type. Because this data set has already been processed, they have 4 different chest pain type, but it's already been processed with 0 to 3. So if I go back to the description of the data set, okay. Which is this, these are the different chest pain type. A typical non-angina, asymptomatic, and typical angina. So those in the medical field understand better. So we're not going to be clear on that. Let's go back. Okay, so moving on, just want to view the data set again, then do a correlation of our data. Find the correlation between the independent variables and the target column. So you understand better if I just put it in a plot so to know the correlation of our data sets. All right, so from our data, I believe you can see the screen fully. This shows the correlation of our data sets. Here, the TALACH and the CP are more correlated. Correlation of 0.4 to 0.43. So this will give you an understanding better when doing your modeling. So this shows the correlation of the independent variables to the target column. So what we'll be doing is just exploratory data analysis. Now I want to get into the business proper, which is our modeling. So let me just view the data again. These are data sets. We're working, these are target column. So splitting our data into X and Y. Split our data into X and Y. Don't need to view the X and Y. So split our data into train and test sets. Let's run this again. Okay. All right, so splitting into train and test set using a test size of 20%. Like I always do, I want to use three different classifiers, which is the logistic regression, which can also be used for classification, because this is a classification problem, K neighbors classifier and random forest classifier. So instead of me running it individually as a different code, I just like putting it in a function, just like a helper function. So I'm going to create a function which will fit and score my data with the three classifiers passed on it. So this is what this code is doing, where the random seed of 42, which is random states, to reproduce the same results, and putting it in the dictionary. This is what this code is doing, model scores. And I'm creating a for loop which says for the name and model in this my model items here. It's my three model. It will fit the train data, then it will score the data, that's the SS and the YTS, then it will return the model score. So this is what this function is doing, fit and score function. To create a random state of 42, put them in a dictionary. After it has fit the data set, it will score them and put them in this model scores dictionary. This is what this function is doing. Now let's run this. Then let's call function created. So you see, it was very fast. Instead of running its logistic regression differently, getting a different kind of work differently. So with that function, I just ran the three different models. And from our model, if you can see my screen better, it's like the logistic regression, that's our base model. These are base model. We haven't done anything. Logistic regression seems to do better than random forest, but we won't know if it is overfitting or not. So let's just compare them in a visual so you understand better. So if you notice from this bar chart, the logistic is doing better than random forest, but I'm going to go with the random forest by tuning it. That is actually because this my logistic regression model might be overfitting or not. So, but the random forest regression, they do bad also. So I'm going to tune the hyperparameters of the random forest classifier. So I'm just explain a bit of the hyperparameter tuning. So like I said, we'll be using random search CV and also grid search CV. Random search is a method in which random combinations of hyperparameters are selected and used to train a model. The best random hyperparameter combinations are used. Then for grid search CV, it's a technique to search through the best parameter values from the given set of the grid parameters. That is, it's basically a cross-validation method. The model and the parameters are required to be fed in. So the best parameter values are extracted and then the predictions are made. So that's the difference between grid search and random search. Grid search does cross-validation method and it is exhaustive more than random search. So the difference between both approaches is that grid search will define the combinations and do training on the model, whereas in random search CV, the model selects the combinations randomly. In grid search, we define the combinations. So both are very effective ways of tuning the parameters that increase the model generalizability. So enough talk, let's get on the model. So tuning for both, I'm tuning for logistic regression and random forest classifier. So what this code does for the logistic regression, I'm creating the hyperparameter grid for the logistic regression. If you check the logistic regression model, it has parameters called this C and solver. So if you go to the these parameters in a logistic regression model. So what I want to tune, that's the parameters I want to tune, is this C and solver. Then I'll create a grid of estimators for my random forest classifier. So I want to tune the max depth, minimum sample split, the minimum samples leave, and the estimator. So this is like a grid of the parameters this code here is doing. So let's run that. Then tuning the logistic regression. So we're setting the random seed to 42. Then using the random search CV. In the random search CV documentation, you pass in your classifier. Then after that, you put in your distribution. That's the parameters you want to tune. Then, which is in my grid I've already set. Then my cross validation to 5. And the number of iterations I set it to 20. So for each cross validation, it will iterate it 20 times. So meaning 5 times 20, which would be 100. So verbose true meaning that it will not show me the result as it is tuning. So that's what this meaning of this verbose. Then I'm going to fit it to my training data. So let me just run this code for the logistic regression. So as you can see, it's fitting 5 folds for each 20 candidates, totaling 100 fits. And it has already done its fitting. So let's see the best parameters for our logistic regression. So these are the best parameters. So checking the score. Am I the default score for a classification problem as a classifier estimator is the accuracy. That is the default. Unlike the regression problem, the default score is the R2 score. So for this score is the accuracy score. So you can also use other scores to understand the data set better. But we'll get to that. So this is for logistic regression. If you notice, it didn't really improve better than the former one. We had 0.88. So tuning it didn't really improve better. So we're going to tune that of the random forest classifier using the same thing we did. But this time around, I'm using 30 number of iterations. So let's wait for this to load. It will take a bit of time. Mind you, if you're on Jupyter Notebook, so it depends on the processing power of your laptop. Sometimes it might be slower, sometimes it might be fast if I have a good RAM and rest, but I'm on my Google Colab, so it might be faster, but it will take some time. So waiting for that to load. And mind you, if you have any questions, you can drop it on the chat when I'm done or that attend to it. Let's wait for this to fit. Notice it is in this part, fitting the S train and the Y train. So it's doing 150 feet. It's because I set this verbose to true. If it was false, you'll see it writing fitting 10 feet, 11 feet, 20 feet, 30 feet, and so on. So let's just give it time for it to run and load. As that is running, like I said, if you have questions, drop it in the chat. Okay. So it can also be due to my network bandwidth. Just give this time. So after this, if the value that the score will get, it didn't improve more, you can still do the tuning for grid search CV using grid search CV. So if you notice underneath here, it's still running, evaluating, dispatch, and more. should be done in sometimes when tuning hyperparameters, it can go, depending on the number of feet, it can go as far as hours when you're tuning your hyperparameters. So okay, voila. Okay, it has run and fit. So let's check for the best parameters. One model said the best parameters was the number of estimators was 260, minimum sample space 16, minimum sample sleep 17, max depth 3. So now let's score. So with this, if you notice it improved better than the base model for the random forest classifier. The first one we had was 0.83, now that's 0.86. So if you're still not satisfied based on this score, you can still do what we call hyperparameter tuning with grid search CV. So since logistic regression model performed better, we'll try to improve it again using the grid search CV. Notice it has 0.88, random forest has 0.86. So we only have a question. Yeah, I'll get to your question after this. Okay, so using the grid search CV with the same parameters I want to tune, it's just like almost the same thing with your random search CV, but now I'm passing my parameters already set in my dictionary using a close validation of 5. You notice there's no number of iterations here. So if you want to understand better grid search CV and random search CV, you can go and check the documentation. So yeah, I saw your question now. I'll give a reply when I'm done with this. So let's do it. All right, so this was very fast. Okay, getting our score. So this is 0.885, and my random forest as far as did 0.8. So meaning, like I said before, I said I will use random random forest classifier. But with this results I've gotten after tuning, I think I'll go with my logistic regression. And that brings me to your question, Olajide. You mentioned that you would be using the random forest classifier because there may be overfitting in the logistic classifier. So does that mean that random forest classifiers don't have cases of overfitting or underfitting? Of course it does, but to explain better, if you go the difference between logistic regression and the random forest classifier or the random forest estimators, they are built on ensemble, there are ensemble methods, that's the bagging and ensemble methods. So I don't know if you understand what I'm trying to say, but if you go back to the documentation, you understand what I'm trying to say. Defaultly, it has already been worked on that whatever form of overfitting or underfitting, it has been worked on based on, say, bagging and ensemble methods. That's like trees, decision trees. That's the random forest classifier. That's the random forest estimator, because we have the random forest classifier and random forest regression. So why I said that was because it tends to perform better than the logistic regression. So, but after carrying out my hyperparameter tuning, I can decide to go on with this logistic regression. So in your spare time, you can work with both, with your random forest classifier and the logistic regression to do your analysis. Okay, at the end of the day, which of them perform better when you pass this model to a foreign data? Because mind you, what we're working with is split our data into training and tests. So even after working with this, you can save this model and test it on the foreign data. So you see if it performs better in on that foreign data. That's your random forest classifier or your logistic regression. So both of them might have cases of fitting or underfitting, but personally, in my opinion, I prefer the random forest classifier because it performs better in terms of overfitting. So I stand corrected. You can also carry, that's why it's analysis and all, you can also carry out your own survey to understand to see which of them you do. So after carrying out my grid search CV and random forest round search CV, I tend to go with the logistical question. So I don't know if I've answered the question, Ismail. If I have, you can drop it in the chat if you understand. So predicting with, okay, wonderful. So making predictions with my logistic regression. Let's see our whiteboards. Let's see our white text. Vision mode. Wait for this to load. My network is slow. In case of any other question, as this is loading, you can drop it in the chat. I'll reply. Think my network is slow. That's the difference between Colab and Jupyter. Jupyter is offline, Colab is online, so I will do network pass. So I will be able to, okay. Oh, wow. I think my runtime just went out. Okay, wonderful. All right. So, creating the confusion matrix. So, in classification, there's something called the confusion matrix. I think I'll leave that for you to go and read more on that so you understand what is confusion matrix. But I'm going to plot a visualization to get to understand what this confusion matrix is all about. So basically, there are true negatives, positives. Sorry. So let me just run this so you understand what this is doing. So this cell here just puts these values in a more understandable vision. So in the confusion matrix, there's something we call the predicted label and the true label. That's the true positive, false positive, the true negative, and the false negative. So in this visual here, this is the true negative, this is the false negative, as my cursor, then this is the false positive, and this is the true positive. So what the confusion matrix is explaining how well your data set is generalizing. That's how well your model is generalizing, with the predictions. So to understand better, just go back to what we call confusion matrix in scikit-learn classification problem. So you understand what are true negatives, true positive, false negative, and false positives. So moving on, let's press the classification reports. And mind you, in classification analysis, that's classification modeling. Unlike regression, where you have the mean absolute error, the root mean square error, the mean square error, root mean log error, whatever. So what to use in analyzing your model yeah, should I say, we have the precision score, the recall, the F1 score, and the accuracy. So the classification reports will print out the values of everything. So we have our precision score for both the yes or no, then our accuracy score was 0.89. It's rounded off to 2 decimal place. So moving on, we're going to evaluate our model using the precision, the recall, and the FR score using the cross validation, we call it crossover score. Mind you, our base model score, the default score is the accuracy. So to know better if how your model is performing, you can evaluate it using the other evaluation techniques here. So depending on the problem you're trying to solve, that's when you know when to use each of these evaluation techniques. Sometimes the accuracy score will be better when you are making predictions. Sometimes it will be the recall score. Sometimes it will be the FR score. So when you are familiar with what you're trying to solve, that's when you know which of these evaluation techniques you are going to use to test your model. So the cross-var score is a function in scikit-learn package which trains and tests a model over multiple folds of a data set. So this cross-validation method gives you a better understanding of model performance over the whole data set instead of just a single trend test fit. So that's the difference. So cross-var score is used as a simple cross-validation technique to prevent overfitting and promote model generalization. Enough talk, let's get down to the code. So checking the best parameters of logistic regression using the random search CV. So creating new classifier with the best parameters. So these are classifiers which are modeled. So the cross-validated accuracy, you can check the cross-var score for each of them, the accuracy, the precision, the recall, and the F1 score. As I'm saying this, you can do your research later to know what this estimate, this evaluation techniques are. There are many as well. So what this code is doing is going to score, passing the data, the model, the X and Y data, and the scoring. The scoring is set to accuracy. So let's see that cross-validated accuracy score. Instead of a single train test split, it will cross-validate it. The default cross-validation score will cross-validate it 5 folds. That's the default. Let's see if this will load. Okay, as you can see, you have the CV none. Okay, if you don't pass any cross-validation, it will be none. But so I know the default -5, so even none. Checking the precision score, cross-validated precision score 0.82, not bad. For the recall score, and also for the F1 score. So if you notice, the recall score here has 0.92, the precision is 0.82, the accuracy is 0.84, the F1 score is 0.86. So with these different evaluation techniques, depending on what you're trying to solve, you know the one to go for better. So let's put this in a visual to understand better. In our cross-validated classification metrics, we recorded better than the accuracy. So this is just to show you what those scores are. So checking the feature importance of our model, which feature in the data is affecting the model, that's how the model is generalizing. So we're going to check our model, which is CLF logistic regression model, then hitting it again, checking the coefficients of the model, then putting these features in a dictionary. So these are the features of our model. That's the importance. So let's visualize this feature importance. So if you notice in our model, this is the negative part, this is the positive part. The main feature that's important in this model is this CP, which is the chest plate type. It has a score of 0.7. 0.66. So this visualization is showing which of the model features is important that is affecting your model. So, and if you notice the sex doesn't really affect it much because we're going to the negative part. So let me explain better using this. So some are negative, some are positive. So the larger the value, which is the bigger bar, the more the feature contributes to the model decision. So for this our model, the CP feature contributes more to the decision of the model to say, okay, if this person has a heart disease or not for this particular model. So if the value is negative, it means there's a negative correlation. If it is positive, it means there's a positive correlation. For example, the sex attribute has a negative value of -0.94, which means as the value for sex increases, the target value decreases. Means as the value for sex increases, in our model, it has already been processed for female 0, male 1. So as the value increases, meaning that if it's going to male, see that the target value decreases. So the value for the sex, for example, as it's 0 for female, 1 for male, as it's increasing to the male, the target value decreases, meaning the target, which is if it has heart disease or not, as it decreases. For now, so I'm using 0 and 1, as it's decreasing from 1 to 0, means they don't have heart disease. So I'll explain it better with codes instead of speaking this English you don't understand. So this becomes more clear by comparing the sex column to the target column. Let's do a cross tab. You see, for the sex, which is 0 for female, 1 for male, you can see that when the sex is 0 for female, there are almost 3 times as many people with heart disease than without. So meaning there are almost like 3 times as many people with heart disease in this. I don't know if you understand better. Let me see go on. And then as the sex increases to 1, which is male, the ratio goes down almost 1 by 1 for people who have heart disease and who don't. So this means that the model has found a pattern which reflects the data. So looking at these figures and this specific data set, it seems if the patient is female, they are more likely to have heart disease with this particular data and what our model has predicted. So that's what this means. That's how you know the feature that's affecting your generalization of your model. So let's plot another positive coefficient score, the slope and the target. So the slope is the slope of the peak exercise ST segment of our data set. So these are the values. So according to our model, there is a positive correlation, not as strong as the sex and target, more than 0. So this positive correlation means that the model is picking up. So the only security of this our data, what it is predicting is that the pattern we found is that it seems that if the patient is female, they are more likely to have heart disease according to the data provided in this data set. Let's go back to the data. That's what the model is saying. Say if patients are female, they are likely to have heart disease more, given all this other column, cholesterol and all that. So basically, that is how you run the machine learning model classification to see if a patient has heart disease or not. So what we've covered so far, we've done analysis, we've done modeling, we evaluated our model and all. So I guess you've gotten a grip of how machine learning classification, modeling, and analysis is done. So we've come to the end of the session. So if you have any question, drop it in chat and I will reply. If you have any question, drop it in chat. I hope you've gotten a solid understanding of what we've been doing so far, from the analysis to the modeling and also to the evaluating of the model. So I guess I'll stop sharing my screen now. So any question? I have time for question. Any question? Okay. Arish, if you have a question, thanks to share. Okay, you're welcome. If I get you where you're saying thank you for the session. Okay, I guess everybody have gotten a good understanding of this. If you still don't, this session is available on our YouTube channel. You can always go back and view all we've been doing since, and in your free time, get to understand, do your research on the evaluating metrics of machine learning classifier, accuracy score, cost score, F1 score, and more. Then your classification reports, and also the confusion matrix, which is true positive, true negative, false positive, false negative. So basically, you can go back and do more research on it to get a clearer understanding. So in the absence, thank you very much, Lajide. I'm happy everybody got good understanding of it. So in the absence of no further question, I guess we'll call it a day. Thank you very much for joining us. My name is Gino Christian, data scientist at Family. See you next time. Have a lovely day.